Okay, video 2 for the incline plane lab number 2. All right, so we talked about the precisions. Now I want to talk about sources of error. All right, when we talk about sources of error, we need to be very specific. First off, we only talk about sources of procedural error. That is, error that could have affected the results while doing the procedure. Calculations, converting, you can't use those as sources of error during the procedure. All right, that's a different part of the lab. So, a few things you might want to remember. Whenever you have an object that is moving, sliding, rolling along another object, there's always going to be some friction involved. In the case of this particular incline, I'd like you to notice, and you can focus in on the way this is made. All right, this is actually two parts that are fastened together right here in the middle. So as you can see, there's a seam or a joint right there. And the car wheels have to roll over where that is. And sometimes you can actually hear when it does it in the mid-movement. Okay, then of course, some of you rightly indicated that when I released the car, I might have given it a little extra push. Well, I hope I didn't. I hope all I did is release it. But there is that possibility. So that was a very good observation, and you can, of course, use that on this one as well. There's also the possibility that the clay ball doesn't stop and hold the car, but it might bounce back and the flag break the beam again, which, of course, could affect the result of what we see. Now, we hope that doesn't happen. I don't think it did in this one, obviously, but it is a possibility. So, obviously, there's a number of things we can look at. Some things we cannot look at here. We cannot look at wind affecting the car. Guys, it's negligible. Any air resistance here is negligible, and there's no wind in the classroom anyway. We also do not talk about reading the instruments incorrectly. That's a cop-out, okay? We're trying to do a lab, so we're trying to take careful, precise measurements. So reading the instrument incorrectly is a cop-out. I don't want to see that again. All right? So those are some of the things that you look for. If we were using a ring stand rather than this very stable base, I don't know if you've ever noticed in chemistry, but sometimes when you screw the rod into the ring stand base, even if you get it screwed in tight and you set it up on the table, for some reason those rods want to kind of wiggle back and forth, and I don't know why, but if we ever do a lab with a ring stand, now you know that is a possibility because I've seen some of the ones that I use do that. So there's all sorts of things to look for when you're talking about procedural error. And that would be in the manipulation and the construction of the equipment that you're going to be using. Those are the things that you need to look for as sources of procedural error, okay? The one thing we never say is human error. That is a big, big no-no in the scientific community. I don't care what they taught you in middle school. We don't say human error. If you think there's something that you did while doing the procedure that could have affected it, then you need to be extremely specific about what that was. Okay? All right. I think that's about it. And thanks for watching the lab videos. And you can now get to finishing your report. Okay? Bye.